Okay, so we got about 15 hours of print time on this thing, and I still don't have a great calibration for the X. Y is not horrible, but we're fixing that right as we speak. Um, I got my controller box made for my graphical display. It's got a notch cut out here for the SD card. Got my potentiometer so that I can move through the screens. I like it. I gave this is my I still have to do this up, but I gave her a haircut and added new DuPont connectors to the servos and got rid of about 10 feet of wire that didn't need to be here. So it's looking nice and clean now. All in all, super happy with the print quality. I mean, look at that. Do you see any banding on that? I mean, obviously there's layers. There's always layers. It's 3D printing, but compared to what I was getting off the 2-up, there's nothing wrong with that. And that's 0.2 millimeter layer height. So that's not even I can double that resolution. But since my X and Y aren't calibrated right, if you don't orient two parts that are supposed to be the same, if you don't orient them the same way when you print them both, then you wind up with funky angles, holes that don't line up, amongst other things. So I have designed in Inventor this square marked X and Y for the axis. It's 100 millimeters. So you print this, and actually I figured out in Inventor how to export an STL in millimeters. So you shouldn't have to scale it. It's just 100 millimeters. Oriented on the bed so that the X is the X-axis and the Y is the Y-axis, like I have here. You print it out and you measure it. And I measured the Y to actually be 102, 43, and then my X-axis is actually 97, 15. So you take what it should be divided by what it is times how you got there in steps per millimeter. So my current Y was set for 80.88 steps per millimeter. And then that gives you your new steps per millimeter. Same thing for the X. What it should be divided by what it is times how you got there. And that gives you your new steps per millimeter. I'd done this on a 20 millimeter calibration cube, and I'd got it down to what I thought was 0.02 millimeters. But I decided really you need a larger base. As you can see, that small variance over a larger scale, it multiplies. It's not just additive. So hopefully this will give me closer quality parts. Next read is, oh, check out my little nut holders. See my little nut holders rocking away down here? No jiggle, no wing nuts spinning around due to bed vibration. And all I got to do is drop me an Allen key in there. I can raise and lower the bed. Good to go. Don't have to reach down there and try to get that thing back there, which is usually like right in here when the bed's out. Big plus. First mod right there. First mod. Next mod is going to be this little Y idler that I hate so much. I don't have a good enough light so you can't see this, but see how far to the side my belt is riding on that? And you really can't tell But this belt is half worn in two already. I got this little pile of shavings right over here, and I'm gonna be lucky if I can finish printing tonight before that belt snaps. But you can guarantee yourself I've got more coming from Amazon. But we need to redesign that Y idler. That is my next design project. I want to create something like more like a boat roller that's got some wide, like a wide V flare that still uses the bearing, but probably just one of the bearings. Or I'm just going to make a sleeve that fits over both bearings. But it's going to be tight. But I got to do something, because you can see that belt is half worn in two. Hopefully yours won't have this problem, but mine sure as crap does. So let's see how close I got on my my next calibration. Looking a little better. Looking a little better. I'm gonna have to pull the part off of there and take an accurate measurement, but you know, 0.2 millimeters over 100 millimeters. That's not as bad. Maybe we'll tweak those numbers a little more.